Today I'm going to talk about low power wide area networks. LPWAN, I think they have been very commonly discussed in the industry and especially in the IoT connectivity field. And with this webinar, I just want to give you some background why there has been discussion about these and what are the different technologies behind it and what you need to consider if you want to go into the direction of low power wide area networks and which technology to use in these cases. So just let me give you some organizational information at first. So this will be the agenda today. We are just going to talk about cellular and non-cellular low power wide area networks. Some comparison of Sigfox, LoRa, narrowband, LTE-M, Cat-M, as well as Cat-1. Some cellular features really that are new with this LPWAN and provide a better power consumption for cellular networks. A real cost comparison of modules and connectivity. I think when, let's say, 2015, 2016, the standardization took place, there were some estimated costs, but basically I wanted to get a real cost understanding of what is the price of the certain modules and also of the connectivity if you choose any of these technologies. And in the later part, I then want to show you the support of EMnify, of which cellular low power wide area networks we support and in which territories, and also provide an example LTE-M use case of one of our customers. Last but not least, there will be a Q&A session. So please, if you have questions during the presentation, don't hesitate to write your questions in the questions panel on the right of the GoToWebinar menu. Or at the end of the presentation, I can also open up the microphone for everyone so that you have a possibility to ask questions directly. Okay, with that, I would then start the presentation and just give a short idea why there's a need for low power wide area networks. So if you look at the cellular connectivity, you have an approach, if you look at your smartphone, which is always bigger, better, faster. Yeah, so basically all the modules, devices, they try and the technology tries to optimize download speeds and with that have a very complex module inside to do to provide the connectivity. So a lot of different technologies are introduced, like multi-carrier or LTE advanced, and basically everything goes into the direction of 5G mobile broadband, where you're then able to stream any HD stream, so basically which gives you, let's say, infinite bandwidth. On the other side, there's large demand of IoT use cases which are not where bandwidth is not really relevant, right? So in IoT, I may just use a couple of bytes to send data to about the temperature or about the fill level of anything of any device to a central location, and I don't need any of the high bandwidth speed. So therefore, in 2011, 2012, Sigfox and LoRa actually started something new, which was by that time then also coined low power wide area networks. So really focusing on IoT use cases with, let's say, 4 main advantages in mind. One thing is really cost saving. So instead of supporting all these different features from LTE, just use very simple logic and provide simple modules for the sensor so that they can be very cheap. Longer battery life. So basically, you know that from your smartphone very well. If it doesn't get charged every 2 days, then the battery will be empty. These devices for IoT, you want to have basically years in the field without there needs to go somewhere that needs to touch it and change batteries. And so you basically just want to have a device that stays there until the end of the sensor life and not until the battery is drained. So Sigfox and LoRa, they formulated the goal to have basically a battery life of 10 years plus with a normal coin cell. Another thing is also better coverage. As you know, with cellular technology, you have challenges with indoor coverage or below ground coverage, but these are actually, there are some very interesting use cases in industrial IoT or IoT, especially for these use cases, also in rural areas where there's no cellular connectivity available. So LPWAN really goes into the direction to improve the coverage also to areas where there has not been any coverage before. And last but not least, if you think about sensors, you want to keep them as small as possible so they fit in any cage. And the device can be put anywhere without really impacting the physical dimension. So these LPWAN devices usually have a very small form factor compared to traditional modules. As you can see here on the lower left, there are some technologies that evolved from the cellular side. This is LTE Cat 1, Cat narrowband 1, and Cat M1. So these are, let's say, the first that's the first release of narrowband IoT and LTE-M, but there's actually new specifications now out, and the first devices available with Cat NB2 and Cat M2. So there's let's say, a continuous improvement on the cellular side in the direction of 5G machine type communication, which is the, let's say, IoT domain for 5G. Just to present a little bit of a categorization of the LPWAN technologies that are available, just a few of them. There are other proprietary technologies available, but the, let's say, three main ones on the proprietary technology are Sigfox, LoRa, and Weightless. And all of them, they're not standardized by 3GPP, but they either have an open specification available or use some closed ones. But at the end, it's really three technologies which did not have any infrastructure before. So in all these initiatives, new infrastructure is built up, especially for this use case. So optimized really for these low power, low data devices. The only thing that is, let's say, or one big thing that's different to cellular technology is all these approaches need to rely on a shared medium. So opposed to cellular technology where operators are buying spectrum licenses for a lot of money, the providers of Sigfox or LoRa weightless technology, they cannot use this licensed spectrum. They need to rely on unlicensed spectrum, which is shared between other technologies, like maybe like Wi-Fi or even push-to-talk communication. So that puts a burden on these proprietary technologies. One is interference, because they are not the only ones using this spectrum. And then there's also usage regulations. So it's not possible, as a device to send in this shared medium 100% of the time because you would interfere with others. So there are some usage regulations that, for example, in the EU, maximum 1% of the frequency band can be used by one device. In general, I would say that the proprietary technology is more an open ecosystem. So there are more partners where you can join, or even in the LoRa case, you can deploy your own gateways or own infrastructure and provide connectivity yourself. Whereas in the telecom side, on the cellular technology, it's all using telecommunication infrastructure. So very expensive from a point of view of deploying, but as we know, telecommunication infrastructure is already ubiquitous, rolled out everywhere. But on the cellular side, it's a very closed ecosystem. So you just have 2 or 3 operators per country, sometimes 4 or 5, but it's nothing where you can let's say decide, I want to do something different. I want to have coverage anywhere there. This will be really steered by the mobile operators. A short introduction about Sigfox and LoRa. So both, interestingly, were, let's say, founded or originate in France. Sigfox is like a new independent network operator with, let's say, specific Sigfox operators in different countries. And Sigfox, like LoRa, they're really optimized for sensors transmitting low amount of uplink data. So each of their gateways provide a larger coverage area than we used to from Bs or let's say from cellular technologies, because they're really optimized for it. Sigfox you have the option, just to give you an idea what's the targeted use cases. Basically, you have a choice between 2 messages per day to be sent with 12 bytes or 140 messages to be sent per day, and each message is 12 bytes. So if you're thinking about streaming or even sending pictures, this is definitely not in the scope of Sigfox and LoRa. Also worthwhile to note, because Sigfox, also the gateway has this fair usage policy, it cannot use the spectrum as well. There's a hard limit in both technologies on the downlink messages. So in Sigfox, you can send 4 downlink messages, 8 bytes. In LoRa, you can send 10 downlink messages based on the fair use or policies. In general, there's a wide adoption of both technologies. I put the links here about the coverage. Let me just put this up, and then you can see basically where there's a global coverage. Very widely deployed, also Latin America, many countries, also countries which are not the typical LTE countries, I would say, where there is still LTE rollout. So where basically LoRa and Sigfox, where Sigfox has an advantage compared to narrowband or LTE-M, because there's actually available. Also, for LoRa, there's a similar link here for the LoRa coverage. The only thing to note here is that basically LoRa is not a single provider like Sigfox, but it's really like a membership type of approach, where a lot of companies are providing the coverage and coverage map. And each of these operators is kind of standalone. Yeah, so I see here that 140 countries with LoRaWAN deployments and 170 network operators are out there. So some operators, they have really multiple countries included. Others, they're just deployed in specific countries. If you intend to build up a new network, you can do this as well and join the LoRa Alliance. Okay, so one thing I wanted to point out is why was LoRa or is LoRa and Sigfox so successful in the past is based on the fact that cellular connectivity is really not optimized for IoT in terms of energy. So if you look here at the picture or on the GIF, it's really cellular connectivity is meant for conversational voice. So if I call my buddy, I really want to have a connection within 1 or 2 seconds. It should ring at his phone and he should be able to pick up. So this is why every device is listening continuously on the radio to identify, is there a call for me or not? So there's always paging happening, and I'm listening if there's a call for me. Now there have been some improvements, for example, in release 11 for a traditional smartphone, let's call it this way, power saving, which is called eDRX. Basically, it's like here the blinking from Lisa. She's not looking all the time and looking for a new message for her, but has a 2.56 seconds power down in the middle. So if there's a call in that time, she might miss it, but then it's just a small delay until the call is realized. And then there's another thing which drives energy consumption, and this is something which is called periodic tracking area updates. So basically, every device tells the core network where to currently route the call. So it's like Lisa would be calling her friend where she's waiting for the call. Hey, currently I'm at home. And then 54 minutes later, calling, hey, I'm still at home. If you want to reach me, call me at home. Yeah, or if she's moving to a different territory, to a different place, then she would be calling and tell the core network basically where she's at. So this is here just to show this a little bit graphically, how this would look like. Every 54 minutes, there would be this periodic tracking area update where there's proper data sent. And then there would this, let's say, be the idle mode, but actually in this idle mode, the device is still listening if there's a call or if there's any communication that is relevant for that device. So this gives you an idea that actually the device for IoT, which just has to send maybe once, twice, or a couple times per day, this pattern is not really meaningful and drains the battery faster than necessary. And this is where Sigfox and LoRa has their strongest advantage because they're not following this pattern. So what happened was in 2016 that there were new features standardized for IoT or cellular IoT connectivity. And two main ones that are relevant here is the power save mode and the extended discontinue reception mode. So it's let's say a longer, this extended discontinuous reception is a longer blinking basically of Lisa. She's not listening, she's waiting longer to go to sleep and then wake up, and that's basically here this extended eDRX period. This eDRX period can be set up to 40 minutes now, not anymore 2.5 seconds, but really 40 minutes. So this means that really the device can power off for a very long time or for a larger time. And then there's the power save mode, which is basically giving the device the possibility to really go to sleep for up to 413 days without needing to tell where that is at. So the device just tells the network, I'm going to sleep for a specific period of time. And if you have something to send to me, don't expect that it will reach me. You may buffer the data that is sent to me, or you throw it away. I don't care. I will go to sleep. I still want to be registered so that if I send the next time, I don't have to attach again. But I'm going to sleep and will send data when there is data. So this means the device is still able to wake up and send the data when it's needed. So if there's, for example, a new alarm coming up, there's a threshold is needed, and now I need to send something, the device can power up again and then send the data. But if there's someone, an incoming connection, it would not receive it. And then there is this idle timer. So usually if a device transmits data, uplink, to the antenna, then it also waits some time until to get some acknowledgement or to also get additional data on the downlink. Now, this time is specified with this T3324 timer, and now this timer can be set to lower periods, down to 16 seconds, but can also be set to 0. So basically that then the device is not listening at all to downlink connection, and with that improve the battery lifetime again. So so that's probably the two most significant changes on the cellular side to improve battery lifetime. There are some other cellular IoT features which were introduced to meet these requirements that I was pointing out in the beginning, like better coverage, lower device costs, and longer battery life. One feature is the coverage enhancement feature. There's two different modes, CE mode 1, CE mode B. Which is just giving a possibility for devices to transmit the data multiple times. So in CA mode A, you basically can send the data 32 times, and then the base station can see, okay, did I any of these 32 transmissions would then be sufficient that the data is really properly transported. And with that, you have an additional coverage gain. So which is, in dB like 20 dB. And with this coverage enhancement, now also you have indoor coverage or underground coverage, something which has not been reachable with regular LTE connectivity before. There's also the CE mode B specified, which gives up to 248 times repetitions. As of now, as I've seen in the market, only CE mode A devices are available, but CE mode B will be coming out soon, which gives another coverage enhancement. And then there's there are new classes of transmit power devices, because now basically narrowband and LTE-M, they have larger coverage. They can also use lower power. So, they, instead of using 23 dBm, they use 20 dBm and would still be reaching the same antennas like LTE has done before. So they would actually use less power to transmit the data. So in regular LTE, it's usually 23, sometimes 26 dBm. With LTE-M, you have the 20 dBm power class. And also now with narrowband Cat2, there's a new power class 6, which is 14 dBm. There it's still unclear if it's also available in LTE-M. A last feature I'm going to present is just the control plane optimization. So, oops, there's my graphic is missing. So I'm just going to do it verbally. Basically, if a device connects to the network, usually it does first a single link connection and then send data over a data path. With this feature, it's actually possible to skip the real data path and already send data over the signaling path. So this allows the device to stay just online for a shorter amount of time, and with that save battery and again optimize the IoT use case. Now, the cellular feature availability that I was just presenting is available based on different technologies. So LTE Cat 1, which is very standard deployed right now, already supports this power save mode, as well as LTE-M and narrowband IoT. So you see here in the table which features are available on which technology. The control plane cellular IoT EPS is mandatory for narrowband IoT and is still in question if this is going to be deployed for LTE-M or Cat 1. But as said before, I would say that these two are the ones that are providing the most power saving for these devices. Now there's three things if you want to go ahead and deploy a cellular low power WAN cellular device. You need to basically, besides checking if this technology is available in the area where you want to be deployed, you also need to check if the technology really supports this feature, if the device supports it. So there are even LTE-M or Cat 1 devices available which do not support a specific feature. So you always need to check the device specs, as well if the network supports it. So we have, for example, some networks here in Germany which offer LTE-M connectivity, but as of today are not supporting extended eDRX, just because the network is yet not at that stage. So these are the things that, once you decide for it and you have a testing phase, you should validate if you're really making use of that feature. So overall, I was trying to do a comparison of the different technologies. And here you can see a summary, like with thumbs up without boring you on, very specific radio stuff, but really from a deployment perspective, right? What do you need to consider if you want to deploy a low power WAN technology, for example, to replace 2G? Then you need to consider really practical things. And Cat-M and Cat 1 are the only ones that are supporting voice, but I think this is very irrelevant for IoT use cases. It is more something because it's actually an LTE technology that they're supported, and there are relevant use cases in that domain as well, but the main use cases are rather not voice driven. Then you have a data rate that these devices support, and you can see that Sigfox with 100 bits per second is very slow in a sense, but again, if you just send a data that, okay, in Berlin there's currently 22 degrees, it doesn't matter if the message arrives 1 or 2 minutes later. In the cellular side, it's narrowband IoT supports 250 kilobits per second and Cat-M 1 megabit per second. and Cat1 10 megabits on downlink and 5 megabits on uplink. So it's basically there you can already see that there are different use cases. If you have some streaming or picture use case, that falls more in the domain of Cat-M or LTE Cat1, whereas if you have sensors, that is something which can be met with any of the technologies, I would say. There's not in the, I think I presented that before, in the LoRa and Sigfox domain, there are limitations in the amount of messages that can be sent based on the shared medium. In the cellular side, it's basically unlimited. It's really just based on the bandwidth. So it's up to the application to really manage the data to lower the power consumption. Now, from a practical perspective, what does these limitations also mean from messages? So, for example, if you develop an application or a use case with LoRa or Sigfox, you need to understand that you have basically an unreliable transport, because you may send 20 or 500 uplink messages, but you can only receive 10 downlink messages. You will not have acknowledgement for every data that you send. Whereas on the cellular side, this is basically given with TCP/IP, and with that you don't even need to worry about how to manage data validity and data correctness. Also, if you consider these limitations, there is firmware updates that you need to consider. Again, based on the downlink limitations, there is let's say complex solutions available for LoRa that support this, actually with a broadcast mechanism that updates all devices at once. But it's really a complex setup, and that's why I didn't give a thumbs up. It's possible, but I would say it's not for everyone to use. Sigfox will not be possible with just 4 messages per day. Whereas the narrowband Cat-M and Cat-1, you basically have really duplex communication, so it's not an issue to do firmware updates when needed. So if there's a new security patch or anything, then you can roll out a new firmware when needed. Also, remote device access, the same argumentation. If you have trouble with the device that's deployed in the field and you want to understand what's happening with the LoRa or Sigfox, you will have a hard time really connect to the device and send a lot of data because of the downlink limitations. Whereas on the cellular side, it's built in. The largest benefit from LoRa and also from Sigfox, but in a limited sense, is that you can really deploy coverage where needed. So if you have a use case which is in rural areas where there's no LTE deployed or where there's not even cellular connectivity deployed, then you start thinking about, okay, what do I do, right? So I cannot ask an operator to deploy a base station here just for my cattle monitoring use case. So what do? I try to deploy my own gateway and basically use LoRa to implement my use case. So it will be then on the use case developer basically to also deploy the network infrastructure. For Sigfox, this is limited because at the end, Sigfox is also an operator. It's not that you can deploy yourself, so you need to basically make a contract with Sigfox and ask them to deploy the base stations, and that obviously takes time and money considerations into this. A very important part of the comparison for me is the roaming or mobility to other countries. So you need to understand, if you want to deploy an IoT use case, which is not just limited to one cattle farm, but maybe you have really a device which shall be shipped to all cattle farmers in the world, potentially, then you want to have a solution which is able to work anywhere in the world and use the same connectivity. I don't want to use different chips or different identifiers in any other country. I want to have a single identifier. In the cellular space, this is a SIM card, and with LTE-M and Cat1, you're basically now able to roam in any of these countries that support it, and you also have the possibility to roam within the more operators. So that means even if one operator does not have full coverage in that country, you can also use other operators offering the same technology, and with that have a larger coverage. Currently, this functionality is not available in narrowband IoT. They are the first, let's say, operator groups. Deutsche Telekom and Vodafone, they are starting to activate roaming within their groups. And there are the first negotiations about roaming agreements with other parties, but it's not really widely deployed. And as of today, you would need to get a new SIM card for every country that you want to deploy your solution. In the LoRa case, interestingly enough, it's a free ecosystem, so anyone can deploy gateways, but there's also no mobility between the different networks. So that means if you are working with one network provider in one country, then you go to a different country, you basically need a different identification mechanism and need to adjust your solution to that. So one thing that was I talked a little bit briefly in the beginning was really how does it look in the practical side if you do a cost comparison, right? So a lot of the, let's say, discussion about LPWAN, Sigfox, LoRa versus cellular is about costs. And everyone is saying the other is more cheaper or more expensive. So what I did is really trying to analyze what is currently available in the market and how would the costs for someone that is deploying a solution look like. And here you can see, so basically I looked at several different vendors. The first 5 ones, they are basically offering cellular modems. Innocom is for Sigfox, and Murata, and no, Innocom I think is for LoRa, and Murata and Microchip for Sigfox. And have taken different wholesale providers to get an understanding about the costs. And you can see here, let's say the average cost for a Sigfox module is 3.8 euros. For a 2G module, it's 7.2 euros, and so on, right? So you can see narrowband is, on average side, cheaper than LoRa. Cat-M is more expensive than LoRa. And if I have combined solution here, Cat-M and narrowband, it's actually not a lot of difference between the two. I still believe this is narrowband and Cat-M modules are still, I would say, the first, let's say, first phase of modules are now at the end of life, in the sense that are no predecessor modules available, and then we will also see price adjustments, and maybe there will then be a larger difference. I surely think as more people adopt to the cellular modules, that there will be a significant price decrease. And here comparing it, let's say, to the traditional modules, if you look for a 2G, 3G, this would be like 25, just really for the RF module. And if you want to use an LTE Cat1 module that usually has a fallback to 2G and 3G, you're on average on 37 euros, although there are cheaper solutions available that go close to the 2G, 3G, and so on. If you're interested about the price comparison, you can also send me the message and I would send you the Excel file. If you're interested about what LTE-M and narrowband IoT modules are available, here's a link basically from the GSMA website, and here you can see all the different LTE-M and narrowband IoT modules that are currently available in the market if you're looking for a solution. Now, the device cost itself is not the only driver, but there you also have the lifetime cost comparison. So basically also considering the connectivity costs. And whereas on Sigfox, because it's like a single operator, the prices are very let's say standard or openly available. For LoRa, it's a little bit difficult because they are not openly available. There are just too many offerings available. But I have here basically the links to the specific ones here just for Sigfox. Let me pull this up that you see how this is calculated. Basically, you can see here for one device, you pay €9 per year. If you have 2 messages per device per day, you have 140, then it's €20 per year to pay for Sigfox. And actually, it's even if you go here up to 100 devices, it's still the same cost. For LoRa, I have found 2 public available prices. So this is from SimPoint that charge minimum 66 cents. Let me just, you can look at the links yourself then. 66 cents per month minimum if you just transport less than, well, it's 5 kilobytes per month. If you have really more than, or if you have around 400 kilobytes, then you would pay €1.32. There's also an offering from Orange France. So many mobile network operators have also used LoRa, and there you can see for a 3 years commitment, you would pay €1 per month. For 2 years, €1.20, 1 year, €1.50, with no commitment, €2. Now, I was comparing this to an offering that we have with EMnify, just an example for a global basic offering, basically where you have all the major networks in North America, Europe, as well as Latin America, Australia. There with these rates, you would be like at 29-30 cents per month. So this gives you then here a comparison of how this would look like over 12 months, over 24 months with the different modules used. So if you look at 36 months with the Sigfox minimum commitment, basically, of where you just have 2 messages per day, you're still you're quite cheap or very low cost, whereas for the maximum you're already above all the cellular connectivity solutions. LoRa is gradually growing, and even after 5 years, then you see really that as of today, if you use GSM GPRS over a 10 years lifetime, that would be probably the cheapest solution compared to all the others, just because here, I mean, on the cellular side, it's really then the device cost that differentiates it. I want to say that there are other LoRa offerings available. I don't. I think there are also cheaper ones available. It's just giving you an idea what to consider and where we play in the LPWAN domain. So now I get to the let's say the offering of EMnify, right? So you have seen the cost comparison. Now I want to give you an outline. Where do we provide LPWAN connectivity? So if you get a SIM card from us, then you would be able basically to get LPWAN connectivity worldwide. Here the map shows the orange ones where we actually have customer deployments and the networks that are used in these deployments, and the yellow ones we as of today have no LTE Cat 1 deployments from a customer. Would be happy to support you in case of testing. But this is where we basically would have the LTE coverage available so that you can deploy your LTE Cat 1 devices. An updated list of that is available here on our EMnify coverage page, where you see not only 2G, 3G, but also 4G, so whether that includes LTE Cat 1 and LTE-M connectivity. And then there is also the LTE-M coverage that we support. As of today, it's challenging to really test LTE-M because there are no providers available that do that as a global stick scale. So EMnify, we are basically testing all the networks ourselves, and we're gradually adding more and more networks that are supported. So you can see that there's basically in North America, we have already validated the coverage and have large deployments already here. And also in Western Europe, we support the main countries and networks. And there are still some, these yellow colored ones where we're trying to test or where we plan tests to conduct to make sure LTE-M connectivity is available. Overall, the network providers are rolling out LTE-M and narrowband IoT quite frequent. So we see in the past 6 months, there were actually 16 networks in LTE-M that were LTE-M enabled and another 16 from narrowband IoT. So you see that here there's really currently the rollout is happening, and I would not be surprised if by the end of the year the, let's say, color of this map is significantly more orange. You can also look at the coverage. Some operators, they also provide you coverage maps. For example, here in Telia Sweden, where also then LTE-M coverage is available, so that you have an understanding where it makes sense or where does it not make sense to deploy. Unfortunately, because the network operators are still in rollout, these maps are not available for every operator. So this is still in the making because they're just continuously upgrading eNodeBs. Yes, so in general, there's a page from the GSMA which tracks the mobile IoT commercial launches. So this is all the networks that have launched narrowband and LTE-M. But during our tests, we have seen that there are actually more networks that support the technology but are not announced. So if you want to deploy, rather check this page and our page so that you have a better understanding what technology is available. As of today, EMnify is not offering narrowband IoT. We are in negotiation with a group basically that would give us the entrance to get global roaming agreements. So we're looking forward to close agreements by the end of the year. But as of today, we're not offering narrowband IoT. And again, coming back to especially here the roaming capabilities, we see that currently LTE-M is providing additional benefits to customers because they can really deploy it across countries. And for that, I want to give you a nice use case from one of our customers, EcoWaste. EcoWaste is a company that builds smart waste containers, and basically they're sending the fill level of the garbage bin. So instead of a garbage truck coming by every week, the bin itself just tells the garbage truck, please come because I'm full now. And also they have here in Switzerland, there are some communities, there's a need to also weight the garbage for tax purposes, and they have built in, let's say, the method of weighing the waste and then sending that information together with an identifier so that the people are properly taxed. And this company has more than 100 LTE-M devices deployed in France and Switzerland, and are continuously rolling out. One of the considerations that were relevant for them certainly is that in Switzerland there's a 2G phase out, and they were now looking for new technology to consider for their new devices. And instead of going for different operators providers in Switzerland and France, they were using us, EMnify, because they could deploy their devices in both countries and have the same connectivity management platform on top. Overall, we have now more than 80 customers using LTE-M, and the customers is growing regularly. Okay, so this is so now we're at the